Good morning. We're gonna go ahead and get started on our final technical presentation this morning. I'm Paul Giles. I'm with the Cobb County Department of Transportation, and I'm here moderating our final session here. Session is called Promoting Safety Through ITS. We have a number of presenters here, so we'll get started. Our first presentation is going to be, it's called Improving Communication to Drivers. Our presenters are going to be Alan Davis with the Georgia Department of Transportation and Natalie Smusz-Mengelkoch with ICF. And Alan Davis currently serves as the State Traffic Engineer with the Georgia Department of Transportation, overseeing GDOT's Office of Traffic Operations. Previously, Alan served in various roles in traffic operations, including overseeing the department's traffic signal programs and leading the department's connected vehicle program. Alan is a graduate of the University of South Carolina, a professional engineer in Georgia and South Carolina, and a professional traffic operations engineer. Natalie serves as a Transportation Engineering Senior Director at ICF, as a professional engineer and professional Scrum product owner with 22 years of diverse experience. Natalie leverages innovative solutions, existing deployments, and collaboration to make a positive impact through the use of transportation technology to support safety, mobility, sustainability, and accessibility for all. She has a diverse background with transportation systems management and operations and intelligent transportation systems planning and engineering, having led projects within all implementation phases for program development, planning, and preliminary engineering to design, integration, and operations. Her recent work has served clients including the U.S. Department of Transportation, state DOTs, MPOs, and local agencies. Let's welcome Alan and Natalie.
Good morning, y'all. First order of business, going to shorten that down, so apologize about that. So, appreciate you all staying and joining us for this presentation. We're very excited about this project and looking forward to sharing some more with you, and excited to be able to share the application with you here towards the end of the year, beginning of next year. So, we're going to talk about the program overview first, then the project overview, and then dive deeper into where I think you're going to be really interested about how future replicability within your area, within the Atlanta regional area is possible, but then also statewide and then beyond statewide too. So the ITS for Us program is sponsored by USDOT. It's led out of the ITSGA office and joint effort. So we've got folks from OST, FDA, FHWA, all on the team supporting this program and our project success. And so the purpose of the program is really focused on large-scale deployments, innovative solutions for complete trips, specifically to help underserved communities. And when we say underserved communities in this context, we're focused on supporting people with disabilities, people, older adults, people with low income, and so forth. So we are currently in the second phase, which means we made it past the first phase. Woo-hoo. So thank you to all of you in the room that made that happen, and there are quite a number of you, so shout out. And so phase 2 is anticipated to be 24 months. We have a different vision for that ourselves, and so we have gone a little past the 24 months, as have the other program projects. Next we'll be migrating into operations and evaluation phase. And then there is a commitment to operate and maintain the application 5 years post program support. So we're one of 4 sites, and you can see our partners here. They run it as like a cohort, so it's been great to understand, to be able to learn so much about everybody else's project, although I am biased on ours. And Alan's going to tell you why.
Natalie. We're doing a little bit of a shuffle around to keep things interesting, but just a little bit about the project itself. And this really gets to where it kind of started. Have you ever walked on a sidewalk before? Show of hands. You didn't raise your hand back there. I got some questions. So, I mean, you can notice that sidewalks are in various conditions. Sometimes they're pristine and beautiful and brand new, and a lot of times they're degraded, crumbled, non-existent. And you imagine the challenges you can have of going from point A to point B. Now, imagine if you were perhaps in a wheelchair and you needed to get around from point A to point B, go to work, go to the store or something. Knowing your path and how it can be and how difficult it may be to be able to traverse those facilities that may not be in the best of maintained condition. On top of that, there are things like ADA considerations you have to consider. Can I even get over the sidewalk if I'm in a wheelchair or something like that? Ramps and things that may have been present, may have been destroyed through truck traffic, weather, snow, ice, whatever. Having that knowledge about what your trip, what your destination is going to be like, and the path you need to be able to go there is one of the main facets that this whole project aims to really help support. The project area is in Gwinnett County. If you're not familiar with Georgia, it is a northeast suburb of Atlanta. Suburbs probably lightly because Gwinnett County is huge, but it's a very richly diverse area, demographically, economically. Lots of major transit hubs, both with tying into MARTA down to the south, just over the border, and Gwinnett County Transit. Lots of different land use and road uses, high-speed roads, interstates, major highways, local roads, and things like that. And a really large area, too. This particular area serves over 280,000 residents, where the project is located within this blue area you see on the map where our project boundary is for this particular phase. And within all that, there's also inconsistent pedestrian infrastructure. When you look at what the GMAP application, Georgia Mobility and Accessibility Planner, was going to do, we're going to look kind of this diagram, which we've named the Wendy diagram. It's the name of the girl in the wheelchair there. And this is really just the image of the complete trip. So she starts with making her pre-trip plans, where she wants to go, what's the most accessible and safe route, and then moves on to beginning that trip. She receives turn-by-turn directions, gets alerts on where to go and where to move, transit arrival and things like that. When she actually makes it to arriving on a transit provision, the bus driver themselves will receive alert of any special needs that are needed for this particular passenger, and reliability can be improved through things like transit signal priority. When she exits the bus itself and goes to cross the intersection, she can interact with the infrastructure there and get things like extended ped walks to have more time to cross the intersection. All the while, existing infrastructure through connected vehicle infrastructure can broadcast information out to nearby motorists through RSUs of a pedestrian present here and any particular mobility needs that are there. And finally, when she arrives at her destination, she can receive that indoor turn-by-turn navigation of the facility or destination where she's heading. Now I'm going to hand it back to Natalie to talk about some of the features.
Alrighty, so here's the stuff that you want to really focus on. So we are currently leveraging existing systems. So that's part of the concept of the project. So when we pitched the application with ARC, so ARC was actually lead in phase 1. Shout out Joseph Hackers here. And we wanted to have the kind of best chance of replicability and expansion possible. And so as part of doing that, we thought and looked at regional programs that could be leveraged and sort of went from there. So the ATL rides application, if you're familiar with that, the ATL built that off of an IMI grant award, and we are leveraging that application and further expanding it, and we'll talk about what that platform's built on in a minute. The Regional Connected Vehicle Program, which I know many of you have been able to take advantage of that program, joint program between ARC and GDOT to be able to make roadside units and OBUs, or primarily roadside units, available and support the deployment of that throughout the Atlanta regional area. Sidewalk inventories tools, or sidewalk sim as we identify it here, although it's certainly expanded, is a method that Georgia Tech has developed to gather enhanced pedestrian inventory data. And the Gwinnett County Connected Vehicle master plan that was completed had a lot of focus on how to support applications for pedestrians specifically, and so we wanted to leverage that work that had been done there. And then the space-time memory platform, which I will point you to Dr. Quinn in the crowd who can answer any questions about that, but essentially it is Georgia Tech's routing engine that they've developed over several different projects, and it focuses on assigning impedances at the link and node level to be able to inform user-specific routing, turn-by-turn directions. And so want to just speak to how this project is being developed. We're using, and this is part of the requirements of the program, we're using open architecture, and so we're building the application with APIs, SDKs that can be leveraged. It's not a plug-and-play type of situation, so don't get me wrong, but it does make it much easier to replicate. We've got open source software, so the ATL Rides is built on the Open Trip Planner, and if you're familiar with that, or maybe not, Open Trip Planner is an international code, if you will, and you can think of it somewhat like Google Maps, but it's completely open, and so there's a community that develops this code in a collaborative manner, and it's supported throughout. There's like a system of checks and balances to enhance the code, so you really benefit from the kind of the rest of the community's future enhancements as well. So Finland, for example, uses it as their national routing tool. And we're using open standards, so GTFS real-time, and open data, so the data will be available, and specifically the data collection tools that I've told you about. The processes for that will be made available. And then we've got a lot of documentation. So Tom Glucker can tell you about that. Tom, how many pages in phase one? 1,648. 48. But, and Tom did 1,600 of those. So they're all out on published from phase one. We are updating for phase two, so you'll get the latest and greatest and adding system design document, all that good stuff, blah, blah, blah. And then source code, all of that's going to be published and available as well. So ready to move. So we're going to dive into the specific features that Alan was highlighting in the Wendy diagram, and so we'll go through those complete trip steps and sort of talk about the kind of specific things you could pull out. So again, you wouldn't have to do the whole thing. If you were just interested and said, wow, that one thing is so cool, I want to do that in my area, you could just focus in on that one feature. So the pre-trip planning, again, on an OTP platform or ATL Rides, the enhancements we've done is to essentially identify the person when they set up their account, identifies their mobility needs. And so we worked with stakeholders in the community to understand, hey, what are the things that are most important? And I can tell you we had an extensive list of questions that we envisioned we were going to ask folks, and they were like, no, we do not want to respond with all that. So we narrowed it down to like 3 questions, like, do you use a mobility device? Do you walk more slowly? Do you have vision limitations? And so based on that information that the user provides, then we assign 8 primary mobility modes, and then there's an additional 10 categories with the interactions of various vision limitations or such that people indicate as their needs. When they begin their trip, that enhanced pedestrian inventory that I mentioned. So Georgia Tech has done some extensive pedestrian inventory, so you've probably seen folks out there if you've been in Gwinnett, and Dr. Randy Ginsler, if you know him, he's been out there leading the charge as well. And so through that process, they use video detection with like a GoPro that's mounted to the car, and a machine learning process that's been developed for the inventory. And then they go actually in the field with an outfitted wheelchair to determine like smoothness and all of the different characteristics. And then based on those characteristics, each link and node within OpenStreetMap, if you're familiar with that, we're building on that structure, although we have a separate instance of it, gets assigned an impedance. And so based on that impedance assignment and the user's identified travel needs, that is how their route is assigned. So we'll switch it over.
So moving on to the next step, this integration with transit. This is we mentioned kind of two parts of it. It was information to the bus driver as well as influencing the signal system for reliability. So this is built into integrations into Gwinnett County's Enterprise Transit Management Suite and their CAT-AVL and things like that to be able to provide those larger alerts to bus drivers of the needs that are present. So when a user is coming onto the bus and they're alerted of particular needs or presence that's needed there as well. Again, it's built into this, GMAP puts its hooks into that system through those API calls to be able to make that connection happen and the transfer of information. On part of that, too, is ensuring that reliable trip for the transit trip as well. And that's built in through the existing work that Gwinnett County has done for their transit signal priority, leveraging the connected vehicle infrastructure to be the means of communication, and then interacting with the signal system to add a little bit of green time at the beginning of a cycle or extending it to be able to make sure that bus, if it's behind schedule, is able to proceed through at a reliable pace. Again, it's not necessarily about the bus getting there faster, but really that reliable, predictable trip for consistent service is the key part of it. But what is interesting here too, back to this replicability theme, is that this is all something that was built on existing deployments that the county has taken on and leveraging that existing technology to further enhance it for the outcomes for this particular project, which has been a cool thing to be able to see. Once they leave the bus, we mentioned we're going to be crossing a street perhaps to go through there. And this connection into the system here allows for that PED actuation to occur automatically through GMAP. So there's no push of a button per se, and the actual presence is actually calling up an extended walk as well to give extra time for crossing if that's something associated as a need in their user profile. Making this work on this project was kind of interesting. If you are familiar with NTCIP, which I'm sure you all are, this object for this advanced walk is not standard. It doesn't exist yet. One of the challenges of standards bodies is the pace at which they deal with innovation, but that's another rant for another day. And so we actually were able to work with some of our team and our signal controller providers to implement this in a replicable and scalable way, where we receive the call from the GMAP application and it translates it down to the appropriate hooks, and it really essentially simulates an extended press on the push button that would activate that advanced walk if it were with the physical hardware. But we're able to do it with software, and really that's made possible because of these modern signal controller software platforms that can deal with these enhanced features built on modern APIs and things like that to be able to accomplish that. And then we move on to step 5, where we're actually broadcasting this pedestrian safety message, this personal safety message out through existing RSUs. So the county, Gwinnett County, has done a lot of work to deploy connected vehicle infrastructure for several years now, And through that great partnership, we have a lot of existing infrastructure to be able to leverage to send out alerts to equip vehicles of the presence of a pedestrian. And this is tied back into that GMAP application, making that request for actuation. The system then ties it all back in and sends out that alert so that vehicles nearby could be alerted of the presence of a pedestrian crossing. So it's really great to see the V2X ecosystem really scale out in this way to take advantage of it. Lastly, we'll get to the outdoor-indoor navigation solution. So this is actually taking advantage of Bluetooth low energy beacons, BLE beacons, that we would deploy in facilities that provide that indoor navigation resolution that's needed for when you get indoors and your GPS is no longer working too well on your phone. This gives you that very precise location accuracy to provide turn-by-turn locations within a facility. And it leverages some of the solutions provided through these partners, their software development kits, their own proprietary solution for their navigation stuff, but they provide this open development kit to be able to build these things off of and integrate into platforms like GMAP. So tying this all in, and on top of just the turn-by-turn navigations, you can also do things like the elevator is out, or so you need to go down here, or provide those enhanced navigational attributes that may be needed to really make the trip complete from end to end. So if you're interested in learning more and want more resources and sign up for email, go to georgia-map.com.
Yes, if you could all just open your phones and do that now, that would be great. You can give us your email, and that way when the application is out, you'll be ready to receive it, download it, and use it.
I promise not to spam you about why Gamecock football should have won last Saturday. Too much?
And the emails come to me, so I'll make sure he doesn't do it.
But lots of great resources there on our particular deployment of ITS for us, and also the USDOT program there as well. If you want to reach out to us, I'm happy to discuss Gamecock football in detail or this project. Here's our email addresses, and again, the websites for the program itself. And questions at the end or now?
Yeah, we're going to do questions at the end.
Great. Thank you all very much.
Thank you, Alan. Thank you, Natalie. Okay, our next presenters will be presenting on improving communication to drivers. We have Dolores Uttero from Georgia DOT and Anslee Shroeder from AECOM. Dolores is the current Georgia DOT Transportation Management Center manager. She currently manages activities related to statewide Navigator 511 Georgia Operations Center in the Office of Traffic Operations, including its main sections of highway operations and managed lanes, as well as CHAMP. Dolores coordinates closely with Georgia DOT's Office of Information Technology, Emergency Operations, the ITS Maintenance Section, SIGOPS, and the HERO Unit as required. Dolores is a graduate from NYU Tandon School of Engineering with a bachelor's and master's degree in civil engineering with a focus on geotechnical engineering. Anslee is with AECOM and is the Communications and Outreach Manager at Georgia DOT's Transportation Management Center located in Atlanta, where she manages the overall strategy for 511 Georgia's social media pages, public outreach efforts, and marketing materials. Her career spans from tourism to transportation, where she led social media and digital partnership efforts at the Georgia Aquarium prior to her current position. She has a passion for digital marketing and branding and thoroughly enjoys helping the motoring public each day from the TMC. She's an active member of the Time Task Force. Natalie holds a bachelor's degree in mass communication from Georgia College and State University. Please help me welcome Anslee and Dolores.
Good morning. Good morning, everybody. I'm Dolores Uttero, and I'm here to just talk about how we at the TMC use all ITS devices to improve safety by providing real-time communication and information to our motoring public, but also our partners, law enforcement partners, first responders, and also how we have been improving our relationship with the media by implementing several technologies that we have invested on. We have identified several needs, with the increasing demand from both the public as well as, our partners, as I mentioned before, for accurate and timely information related to traffic. And, several challenges we have faced is, delivering consistent information and also on a timely manner. And through that, we have, determined that there is a need to constantly be enhancing our current tools and also investing on different types of technology that will aid us into getting that information not only fast, but also making sure that that information is accurate. So our motorists can be informed on, what type of events are going on the roadway, so they can plan their routes. Also, making those informed decisions and, hopefully help us reduce, major incidents and also help us reduce, those heavy delays that we see in our roadways. And, through our vision, this vision for improvement, we have approached this on a step-by-step way, and to enhance that, as I mentioned, that safety and making sure that we are, our goal is to have that driver satisfaction, and as well as a result of that, making sure that we are continuing to foster strong relationships with our, partners, first responders, law enforcement, and as I mentioned before, the media. And I think one thing to just really emphasize there is the media is able to reach, I think sometimes a lot more, the public more than sometimes we are, and if we're able to provide them, up-to-date information on what is going on the roadway, our goal is to make sure that we have informed motorists of exactly, what routes to take, and if we have a major incident, they can make those better decisions. And our, our goal is again to reduce those travel times through that information, making sure that we are providing that information. One of the main tools that our operators use is DMS. And how are we using this DMS? We make sure we are sending real-time updates related to traffic information. I'm sure everybody on their way here saw at least one DMS on your route. And we are making sure that our operators are posting real-time information related to travel times, or if we have a major event. We are also partnering with major safety campaigns, when we have a major construction event or a major road closure, we do coordinate with the districts to provide detour routes. Also, and all is done within, MUTC guidelines, guidance. This is the image you have in front of you. Just shows the current active DMS. We have 228 active DMS that we have that we use statewide to provide that current up-to-date information. And through the next images, I'm going to show what the ITS team has currently proposed as projects for future deployment of DMS statewide. The department currently completed a project to deploy DMS along I-95. This is one of the projects that we recently completed. And the main focus of this deployment of DMS is freight routes and also our hurricane evacuation routes. Upcoming projects that we have proposed are along these routes: I-75, 85, 185, and I-16. And upon completion of all these projects, the next slide shows you what our statewide coverage would look like when all of these projects are completed. The teal shows you the existing DMS. The blue recently completed, and the red are our proposed DMS projects. This slide just shows you an example of how at the TMC we're using our current DMS. So you can see there's just a variety of messages that our operators are pushing out to the public. You know, travel times, notifications for construction closures, you know, safety campaigns, and everything is just done in an effort to make sure that motorists are aware of what activities are going on the roadway, just to make sure that, you know, we're pushing that safety message across. And now I just also want to discuss other technological advances and technologies that we have incorporated at the TMC to be able to share all information and be able to have all of our first responders and partners be up to date on everything that's going on the roadways, and also have the ability to see this information on real time as that we have access at the TMC. The first one is our Claris videos portal, which is our next generation video system. And what this portal does is it allows our partners, and we have two portals, is our trusted partner portal as well as our media portal. And what it allows is our users, they have access to all of our video cameras, and they are able to create video walls and monitor their specific you know, locations. If they have a specific cameras they need to monitor, or an event they need to you know, keep an eye on or something, they are able to log in and, you know, monitor these cameras. They are not able to move or PTZ these cameras, which you know, that is just reserved for just the operators. And this has been a very good tool for both our first responders, like I said, whenever they have a major event that they need to prepare for. But also this has helped us with media. They use our video system very religiously. We have also deployed a real-time list of GDOT of all of our events that we are monitoring on every day. So what currently we have is there is another page on this, a link on this portal that refreshes every 30 seconds, and it pulls all of our incident data from Navigator. And that, in conjunction with our 511 page that Anslee will cover in a minute, is our media partners they use that information to pass you know, reports through the motoring public. And so the benefits of, you know, our portals, as I said, you know, we have better informed media partners, which in result we have a better informed and safer motorists and the public. And that's increased our satisfaction, and we have increased our partnerships and relationships with our partners, and also with media, which has been a huge improvement for us. Another tool that we use is DriveWise alerts. This is mainly focused with our commercial vehicle drivers, and the way this is used, our operators send georeference alerts to commercial vehicle drivers. And the way we use this tool is if we have a major closure or a major event that has an extended duration. And the way it works is if we place an alert in a specific location, and if a commercial vehicle traffic passes through that specific location, they get an in-cab message alerting them that we have a specific closure or a detour. And what this helps us do is it helps us improve highway safety. As you know, commercial vehicles need a lot more time to slow down, and also they need more time to move over, and they're always, fighting for that space on the highway. It helps us, our goal is to prevent secondary crashes and always, preventing that hard braking, and help them also seek alternate routes if we have a major closure or, a significant delays due to construction or something like, or anything related to that. Another tool we use to alert motorists and provide them, keep them up to date with any major closure or any major incident is our GA alerts. I'm sure some of you are familiar if you have been at any point near, in this area, in Atlanta at all. What we do is whenever we have a major event that is going to have a 3-hour or more duration, we send out an IPOS alert, and basically it's similar to the Amber Alerts that you receive on your phone, but this is strictly related to traffic incidents. I know I said we have our threshold of 3 hours or more, but if we have an event that we know is going to be on the roadway for a significant period of time, we will begin the period of activation sooner, just to prevent that, queues for, being extensive, in the hopes that, again, we prevent secondary crashes and to help motorists seek alternate routes and be better aware and, preventing people from sitting on queues, for 3 hours, 2 hours. And now I'm going to pass it along to Anslee, who is going to cover our 511.
Yeah, Dolores mentioned Claris and how media uses that, and to even give an example, so just a few weeks ago on WSB live morning coverage, there, I guess on Claris, if you don't, use it for so many minutes, it might time out. In the middle of their broadcast, they were showing one of our CCTVs, and it timed out. And the person literally logged in. It was a Claris login screen, and you saw them typing in their information on live TV at like 6 a.m. So we know it's being used definitely by the media, and that's a good thing. But yeah, so I want to touch a little bit about 511, right? So Dolores talked about our DMS, right? How we're really making sure to get this message out in front of motorists, people that are on the roadway, and so this is just another way. So Navigator, our ATMS, GDOT ATMS, there's a lot of information, right, traffic data that is being pulled into that system. We also have our ITS devices, so and Waze integration. Waze is also, we have that integrated into our ATMS. So what happens is that as citizen reporting is happening, they're saying, hey, there's an incident here, there's a crash there on the interstate. That information is able to come to our teams at the TMC. Then they can verify that incident. They can check the ITS devices, CCTVs, if there's calls from motorists. If there's so many in that queue, they can verify that. So that's just another way. It goes into our system. We can also translate that to the 511 site. Yeah, so once that information comes in, you see there's really 3 main components of 511. That's going to be our website, that's our mobile app, and then our IVR. So our IVRs are interactive voice recognition, also kind of our phone system. And the information translates through, and then it's going to be pushed out to the public. And so it's really a really great amount of traffic wealth of information that people are able to access, overall with that goal to just really, like we said, increase communication, but help people understand what's on the roadways. They know before they go, right? They can check, see what's happening, and just hopefully make better informed decisions. Question before today, who's heard of 511? Yay! Who has the app? All right, okay, all right. And if you don't have that, you're gonna download it today, right? Yeah. So this is 511, right? So these are our other components. So we have our app, which everyone's gonna get today. We have our website, 511ga.org. Call us 24/7, 365. And then we're on Facebook, and we're also on X, formerly Twitter. This is a lot of our main communications. Again, we know pushing that information to our app. We do have customizable alerts. We do have emergency alerts. People can sign up for accounts You can even do a geofence, right? If there's an area, you travel a lot, routes, you go back and forth. You can really get customizable with alerts. So this system, it's a lot of how can we make things as easy and accessible as the users, for the users as we can to get that information to them and just, again, keep them safer. So remember I said all the information is being put into Navigator. This is the example of that. So once our operators have put into the system, what lanes are blocked to the incident, the severity of that, that's going to translate over to the 511 site. So this is an example of it. Also, what makes 511 unique is we do have the estimated clear times and event updates that are happening real time. Not all navigation or other apps will have that. So we do have that. That does really help people understand the potential longevity of a certain incident. The DMS, so again, not just on the roadways, that's a great place, you're driving, but beforehand, a lot of people really check those DMS or really saying, hey, what's happening on the road? I'm on this certain area. Or if there's congestion, backup, et cetera, special events that are going on, they want to see what those signs might say. These are also all listed on our 511 site. People can filter, you can check out text report, just a lot of information that GDOT is trying to provide, not just to the motoring public, but also to stakeholders and partners as well. I mentioned social media. So one thing that GDOT that we have done recently and the past little over a year is we have increased our coverage. So we've recognized really the need and also to the importance of being active during those morning rush hours as well as the evening rush hours. So we have extended our coverage as far as social media. And to provide some context of how we're using social media, so we'll have a team, and as incidents are coming into our ATMS, we're going to filter out, and then we're going to actually post them onto our Facebook as well as our X channels. It's really important, actually. It's been a great benefit to media. So we're tagging media, we're interacting with them, we're including hashtags or things as well that they're going to maybe be following and they can go along with. So we're pushing those incidents out there. They're most likely going to have, as you can see, a picture from our website, or we'll either have a picture from one of our CCTVs where that incident is. And then we'll tag them, and then we also provide real live updates. So if there is a lane closure, if all lanes are blocked, as updates become available, that's going to be posted. Once everything is cleared, that information is also going to be posted. So it's constant information that is going out there. Really, a traffic hub is what we've created, and so we've extended that to have cover those early rush hours. So from 5 a.m. to 8 a.m. during that period is when we'll have, actually we have people from 5 a.m. to 8 p.m., but those morning rush hours is where we really have dedicated time for that. And then also to now from 5 p.m. to 8 p.m. So teams have done that. In the first few months that we did this, we saw a drastic increase within the reach impressions as well as engagement and sharing. And so that sharing lets us know from the back end within social media that people are finding this information, right, worthy of being shared. They want people to know, and then as well as media. And also, too, a good thing with media, again, is they are going to our site. They're going to 511 social media pages. They're actually taking our posts. They're putting them on their news articles. They're featuring them on the morning news, which just better positions GDOT and the 511 program as a trusted source for real-time traffic information. And with that, I'll pass it back to Dolores to wrap us up.
So just to summarize, we are dedicated to analyzing and improving communication to have a better informed public, but also making sure that we are fostering our relationships with our first responders as well as media. I know we touched a lot on our relationship with the media, but as we are able to provide them with live, real-time information, fast but also accurate information, we have seen that we're able to be, as Anslee mentioned, a trusted source for all of this traffic information, and we're getting this information out to the public. And as future goals, we want to continue to strengthen these connections and continue to work with the mapping applications such as Waze, Google, and begin to integrate our ATMS feeds into the way that they're mapping our information. As Anslee mentioned, our 511 app shows the duration of our events, but also as our 511 app shows you what lanes are blocked. And that's something that you may not see on, a Google or a Waze, and that helps motorists know, you may need to move over, and it helps you maybe make a more informed decision when you're on the roadway. Continue to expand the DMS coverage helps us also provide that connection with motorists on the roadway when they're traveling on our roads, and just continue to expand technology enhancements. We continue to review additional technologies that can help us better provide up-to-date information to motorists, but also help us analyze the data that we receive, that we have in our Navigator ATMS, and we'll continue to just be able to provide up-to-date information to motorists as well as our partners. That's all. Thank you.
Thank you, Dolores. Thank you, Anslee. Okay, our third presentation during this session comes from Christopher Gallien and Kumari Deveri with HNTB. This presentation covers Georgia DOT's safety data and crash reporting application programs. Please help me welcome Chris and Kumari. Let me read their bios. Chris is a traffic operations ITS team leader and project engineer with HNTB. He earned a bachelor's degree in civil engineering from Louisiana State University and a master's degree in civil engineering from Kennesaw State University. Chris has nearly 7 years of professional experience with background in traffic operations, analysis and modeling, ITS, safety, and aviation. His primary focus at HNTB is assisting clients as a project manager with traffic operations, safety, and ITS projects. Chris is a licensed professional engineer in the state of Georgia. Kumari is a project engineer at HNTB and a licensed PE in the states of Georgia and North Carolina. She works in the traffic operations and ITS group at HNTB, bringing nearly 7.5 years of experience in that role. She holds a master's degree in transportation engineering from Virginia Tech. Over the course of her career, she has contributed to a wide range of traffic operations and safety studies, covering projects from freeways and corridors to intersections. At HNTB, she has been assisting various ITS and emerging technology projects. Welcome, Chris and Kumar.
Probably could have skipped mine because you probably heard it yesterday, but all good. Like Paul said, I'm Chris Gallien with HNTB, and I'll be talking about the crash reporting online tool development that we've been supporting GDOT on over the last year or so, and along with Kumari. So here's the agenda. I know it looks a little daunting, but we'll try to get through it in a timely manner. I know it's the last day. We almost done, y'all. So I'll talk about the team, kind of what the problem is, or what the problem was. As we know in our transportation industry, everything is guided by funding, so we want to be prudent with our resources, so we want to try to map solutions to an identified problem. Some of the consequences, the solution that we developed, the project timeline and approach, the impact, how crash data moves, and what the end user effects are. And then we'll have a QR code up at the end so you can actually scan and get the tool added to your device. So we assembled a dream team for this project. A lot of those folks are actually here. So I do want to shout out HNTB. We have Deborah Vermillion. I'm kind of skipping down a little bit. She's a crash safety SME. She had an illustrious career with TxDOT, and so she was our subject matter expert on the consulting side. And then Kumari, who is actually filling in for Dave today. Dave was supposed to join, but he had a conflict that came up. So I coerced Kumari about a week ago to join me on this presentation, and she agreed. So I appreciate her. She was actually the project manager for the first phase of the project, and then I came in on the second phase. We had a good relationship with GDOT IT. I know a lot of people had some concerns about IT, but we had a great connection with them throughout the life of this project, working with our internal technical team and then collaborating with GDOT. And then listed below is the law enforcement liaisons that we connected with throughout the project. So we work with Georgia Safety Patrol, Motor Carrier Compliance Division, Atlanta Police Department, and several others. And so I think I'll turn it over now to Kamari to talk about the problem, and then I'll pick it up later.
Thank you, Chris. So when we talk about crash reporting here, please do not get this confused with numeric. So what we are talking here is the training manual that the law enforcement officers go through to understand how to fill out each and every field of a crash form. So that's what we try to digitize and make it more interactive. So the current report, you see the screenshot on the right side of the screen here. It's called Georgia Uniform Vehicle Accident Report Training Manual. It was last updated in 2018. It's a 70-page PDF. And the law enforcement officers, usually when they go through training, they go through the entire manual and they try to understand how to fill out each and every form. But once they finish training and they are in the field, there is a chance that they may or may not remember how to fill certain fields. And when they're in a high-stress situation and when they are actually in the field, they might not have time to look through the entire PDF. And even if they do have a physical copy of that, it's almost impossible to find the specific field they are looking for. So going over the current problem, so it's difficult to search, especially in high-stress situations, and the PDF is not easily readable on a phone, and all these inconveniences lead to inaccuracies in the data that's going into the system. Okay, so the consequences of inaccuracy, so an example, we just wanted to highlight a situation. There was an incident that happened where the officer was not able to log in the right location, and the ambulance came into a different location, instead of where the crash actually happened. So it's very important how this data gets logged in. And this is the data that ultimately goes into numeric. So like incorrect data would result in hindering the ability to identify any crash hotspots, and also having the correct crash data would help engineers analyze any design faults and any measures that we can take to mitigate those crashes in future. So 3 needs were identified for this project. One, we wanted to have a tool that has easy search functionality and ability to identify the fields that you're looking for. And the second need, wanted to have this mobile accessible. And the third need, wanted to have it the capability to load it offline, because officers might be in a location where there is no internet, like no network, basically. So those were the 3 needs that we identified, and we took a phased approach to implement this project. We kicked off this project in December 2022. So the first step, like I said, the manual was last updated in 2018. Deborah, our safety SME, worked extensively with day one Bill, went over each and every section, updated the entire manual to latest and greatest. So once we got all the content finalized, we got our technology team, Kailash and others, and we did workshops with GDOT to finalize how the website look and feel. How do we want this to look like? What features do we want to have on the website? So even like the minute things, it might look super straightforward, but things like page printing. So I would think that you would press Control-P and it would print the pages, but it is not that easy. They had to do some background work to enable that. So we finalized all the look and feel of the website, and we deployed phase 1 of it in October 2023. But that was only the website part of it. We still had to have the mobile app and all the additional features we talked about. And I'll let Chris speak more onto that.
All right, thanks, Kamari. So like she mentioned, Kamari took the lead on phase 1, and then I picked up in phase 2. And there was kind of a like phase 1.5 where there was some bugs that got picked up in the initial deployment, and so we worked with GDOT to get all of those fixed before we really kicked off phase 2. And so in phase 2, we really primarily focused on about 2 or 3 improvements and enhancements. One of those, like Kamari mentioned, was a page printing functionality, where within the tool, even if you're using a mobile device or a computer, you can click a page print button and it prints the page, accurately. It's not, hanging off one page or, in a weird way. And so we really wanted to make sure that that was a good experience for GDOT, as well as the law enforcement officers that's using this tool. And like she mentioned, so when we deployed the tool in phase 1, you can access it on a mobile device, but you couldn't access it offline. And so the big thing in phase 2 was that we wanted to create the tool in a way where if you're in a rural area and you don't have good data connection, you can still access the tool if it's previously loaded on your device. We also added a FAQ page, right? So we want this tool to be useful. We tried to anticipate what questions people would have, and we embedded that into an FAQ page, and we're continuing to build that out. And then finally, in June of this year, we deployed the tool to GDOT, and they're hosting the site live on their end. So here's a quick kind of snapshot of the site. I'll talk some more about that in a later slide. But like Kamari said, essentially, we just wanted the data to be the best possible quality at the front end, right? And so I know a lot of us interact with Numetric, potentially other platforms, but the genesis of all of that data is what's captured in the field in crash reports. And so if we can create a tool that makes that crash report data more useful, more quality, then that's going to improve the entire process. And like she said too, smoother dispatch operations, right? We don't want EMTs coming to the wrong part of the site, especially in a high stress situation like a crash, where every minute matters. I think somebody mentioned that in a presentation yesterday, that minutes matter. And so we want to make sure law enforcement officers are able to, intelligently articulate where they are within the site, even in a high stress situation. So this is an oversimplified graphic of how crash data moves. Obviously, there's more pieces to the puzzle, but essentially you start off with the crash report and then you matriculate through other platforms that GDOT uses, like GEARS, which stands for Georgia Electronic Accident Reporting System. Then it goes to Numetric, and then end users like yourselves, traffic engineers, safety engineers can analyze that data. And so the next slide, we kind of hone in a little bit on the crash reports. So again, improvement in the quality of data captured in the crash report has far-reaching impacts. So officers create forms in the field, and then now they have a resource wherever they are in the state of Georgia to access for quick questions that they might have. How should I code this crash? What's the directionality? What details do I need to include? All of that is embedded into the tool. And then some more. So again, who's using this data, right? Safety engineers, traffic engineers, researchers, educators. So no matter what area of transportation we work in, our goal is to make it safer. So even if you're in roadway design, if you're in traffic and ITS, we want the roadway to be safer, and all of that's built on the best data that we can have. So we want our engineers, we want our researchers to have confidence in this data, for them not to have to spend as much time trying to scrub through the data, but that it can be as accurate as possible on the front end. And then, like we mentioned, having emergency responders, giving them the information that they need that they can quickly get to the site and hopefully save lives. So I'll kind of walk through the tool itself. I won't tell you how to use a website, but I'll just kind of hone in on a couple of key areas. So kind of going from the side, you can see there's an executive summary, and then it has a collapsible navigation pane that you can access all the pages. And then on the top, there's a contact us page. And so we want, again, people to be able to reach out to the GDOT PMs that's managing this tool. And so if you have suggestions, if you have questions, if you have comments, something's unclear, there's a user experience that's not good, you can use the contact us page to do that. And then, like I mentioned in the previous slide, we have an FAQ page that has a lot of anticipated questions that we developed that you can access as well. It also talks about how to add the page to your home screen, and so you can access it offline. One of the big features that we wanted to embed into the tool is a really good search functionality. So like Kamari said, if you have a PDF, the best you can probably do is Control F, and then it pulls up every time you see the word crash. And so we wanted to create something that actually maps to the specific pages where that word might appear. And so that's the search functionality. And then, like I said, too, in the first slide, this was a very collaborative effort. We didn't put HNTB's logo on this, but, we supported this project. But all of the law enforcement agents that supported this project, we wanted to give them, their credit that they supported and they collaborated with us as we developed the contents of the site. And then I showed the mobile version of the tool. This was actually a screenshot from my phone. It was about to die. So make sure your phone stays charged, especially if you're reporting crashes. So again, we have the page printing functionality, right? You see the executive summary here. So everything that's in the web version is optimized for mobile. So all of the same content, all of the same information is embedded in the mobile tool, but it's optimized for a mobile experience. And it's used on iPhones and Androids. So that's pretty much our slides. I know I kind of went through that quickly, but we have the QR code here where you can scan the tool and add it to your home screen. That way, if if you want to interact with the tool and kind of, tinker with it and see if it's working well, you can send in any inquiries to the Contact Us page. And I won't say too much about it, but we're actually continuing to help GDOT and GDOT Crash Safety Team to continue developing the tool. We want it to be useful. We want to embed new technologies into it, but that's for more to come. So thank you.
Thanks, Kumari. Thank you, Chris. Okay, so I guess that brings us to our last presentation, not only for this session, but I guess for the technical part of our Mastering ITS conference. So with no further delays, that last presentation is going to be Mr. Ron Knezevich with the Georgia Department of Transportation. He'll be presenting on new data and validation methods. Ron is the state safety engineering supervisor at the Georgia DOT. He uses data-driven practices and leverages a safe systems approach to reduce roadway fatalities in Georgia. Ron's key roles include assisting in the management of GDOT's safety program, which leverages FHWA's Highway Safety Improvement Program funds. Additionally, he oversees the road safety audits within the state, serves as the task team leader for the pedestrian and bicycle task teams, is the coordinator for GDOT's Safe Routes to School program, and serves on the co-chair for the GDOT Safety Research Technical Advisory Group. Previously, he served as the state pedestrian bicycle engineer. Prior to this role, he worked as a research assistant specializing in data science and emerging technologies within traffic safety. Ron strives to utilize innovative and proactive approaches to reduce roadway fatalities in Georgia. Please help me welcome Ron Knezevich.
All right. Hey guys. I'm Ron. I'm the supervisor of the safety engineering program at GDOT, but today I'm talking about data and validation methods for more of the department as a whole. So before I get started, 3 takeaways for you guys today. The first is we have a variety of new data that's available to GDOT, Georgia, and our partners, as well as extensions of staff, and most of that available to local governments as well. Making that validated data for an entire roadway network available can be critical compared to buying that data on a project-by-project basis that can encourage collaboration and cost savings. Then third, this new data can enable new kinds of analysis, and the kind I'm particularly going to discuss today is proactive safety analyses. So most of this data is coming from the Eastern Transportation Coalition. This was formerly known as the I-95 Coalition. It combines 19 different states, including DC, and is focused on connecting public agencies for safety and efficiency within the I-95 corridors. Within the ETC, or the Eastern Transportation Coalition, there's a data marketplace. Different vendors submit their data to the Eastern Transportation Coalition, and it is managed by the CAT Lab within the University of Maryland. So that's where we're currently purchasing most of our big data sets. Within that data marketplace, there's a validation committee. So that is comprised of different people from the CAT Lab, as well as the University of Maryland and the ETC, and different state DOTs. I serve on the validation committee, my manager does as well, and various other engineers across the state. What you're seeing here is just one snippet from the publicized validation study that the ETC worked on for validating different ADT data. So what you're seeing is 4 different vendors submitted data related to ADT, and it was validated on different types of roadway environments. This lets us understand how well these vendors perform under low volume conditions and high volume conditions. Really allows us to compare and know how we can set our expectations. It's not just the traditional data like ADT that's validated there. There's one example of slowdowns being validated as well. There's all sorts of different studies out there, but that is to say not all that data is validated just yet. We haven't quite found the metrics to validate every single data that has been provided through the ETC. The way GDOT gets that data, and Georgia does, is through a joint data purchasing committee with the Atlanta Regional Commission. That's headed up by Matt Glasser, your truly president here, and as well as Sam and various different ARC and GDOT offices. So I think that recently won award, or is currently winning an award right now, this joint purchasing award in the, what's it called, ITS World Congress in Dubai right now. Pretty cool. Though it's GDOT and ARC, we do try to get feedback from CERTA as well as various other local agencies on what kind of data to be purchased through there. So the data available on the ETC is divided into the following categories. We have our travel time and speed, origin and destination, freight, waypoint data, kind of has a few different terms, that waypoint data, volume data, and conflation data. I'll get into a little more details on what each of those mean. And I highlight that waypoint data. That's partly because that's the kind of data sets we don't really have validation studies for just yet, and we're only using for preliminary analysis right now or experimental analysis. So to first find what data we as Georgia wanted, we took a list of the data attributes and found which data attributes were critical as well as desirable for all the different GDOT programs, as well as CERTA and ARC, to help us kind of rank data sets. Then there was another validation study internal to GDOT. Each of the different data vendors provided their data sets and answered a series of questions to kind of see how that data would fit into our GDOT practices. That could be integrating into our internal software or integrating into just our internal practices in general. So the first data set we are going to discuss that we've had for a couple of years now is the HERE data, and you can see that on our RIDIS platform. The RIDIS platform, the congestion scanner that was displayed yesterday from the CHAMP program. It's a pretty commonly used tool. I imagine most of you guys have had, but that's our HERE data for travel time and speed. That same data set from here is on Iteris ClearGuide, one of the vendors out there today. And they have a couple of unique functionalities where we can rank different corridors based on people speeding over the speed limit. Both those tools, RIDIS and HERE, kind of allow for speed to be visualized in 100, maybe 200 which ways. One of my favorite ways to visualize speed data is looking at that 85th percentile speed distributed across the time of day, and kind of seeing that maximum, minimum, and average 85th percentile speed across various days. Then we have our origin destination data, and that's through INRIX, another one of our vendors here today. And the bottom line with that data is we're looking at where, when, which, and how many vehicles are going from one origin to another destination. And that data is on our RIDIS platform and can be visualized in 100 which ways as well that all of you should have access to. Then we have our freight data, and that comes from Geotab on the Altitude platform. And we have travel time and speed, volume, freight reliability, and OD data for freight on that platform. So this was recently had a lesson on with ITE last week. I believe there's a recording of how to use Geotab if you are all interested. I'm actually not too familiar with the Geotab. As a safety engineer, I'm not using too much with freight analysis. Then we have conflation data, simply meaning configuring GIS data in a way that's usable for us. But the one way we're utilizing this now is to take that ADT data on TDA and turning it into links, so something a little bit more usable. The goal is to get that onto the RITIS platform, maybe the Numetric platform, maybe back on TADA. We haven't quite done that yet, but that comes from One Spatial right now. And then our waypoint data, which comes through Replica right now, and we have things such as CV events. So within that data set, we have things like sun braking movements, sun acceleration movements, different speeding events, and phone handling, meaning when you pick up your phone while driving. So that data set, again, this is the waypoint data we're saying only to be used for preliminary analysis as well as experimental analysis as well, not to supplement your traditional safety or operational analyses. Other data sets that are available that we haven't really seen yet on the platform are wrong way driving as well as seatbelt usage data. We also see data related to walking and biking. What you're able to see here is changes in the percent and amount of people walking in different block groups within Atlanta. This can be useful for assessing mode split, particularly on projects like roadway reconfigurations when we want to see how many more people were walking and biking along a corridor after that design was done. And then we have volume data that comes with that. We did not renew purchase of volume data, but it does come with that waypoint data. And again, the goal is to get that onto the RITIS platform eventually, but right now it's just on the Replica platform. And we also have turning movement counts that come with that. And again, only to be used for preliminary analysis and experimental analysis at this point in time. And you can also get different demographic data associated with that ADT and turning movement counts as well. So percent of people in different age groups, minority statuses, as well as a couple of other demographic factors. So why are we purchasing all of this data from all these different vendors on all these different platforms? Because it can save us money. If you purchase this data on a project-by-project basis, we found that in 2022, looking at this, if you purchase it only when it's required on this project-by-project basis, we would have saved around $3.1 million. And that's not including some of the additional benefits that we're getting from, say, looking at that speed data in an early preliminary safety analysis and how that can inform our decisions throughout the whole project's life cycle. And those kind of benefits can be difficult to quantify. All right, so I was asked to speak on new data in an ITS conference, so I had to bring up conflict detection. So a little bit about data outside of the ETC. So the reason I have to bring up conflict detection is because I truly believe what we're doing in Georgia is cutting edge compared to other state DOTs when leveraging this data. And a big thank you to the Adkins team and the Quality Counts team for making it possible to integrate conflict analysis and or near-miss detection in our road safety audit process, kind of just our traditional process with no extra costs. So right now we're using conflicts for vulnerable roadway user safety and simply seeing when vehicles come within under 3 seconds of hitting a pedestrian. So videos such as this. But, oh, and before I show any more videos, GDOT does not own any of these videos. These are owned by the vendors that provide it and only being shown today for research purposes. We are given the data the same way we get count data for our normal processes. But not all conflicts are the same. So in this instance here, we see a much slower moving vehicle, a pedestrian that sees that vehicle and kind of waits for the gap in traffic and simply is not really a safety concern. So there's a lot more to deal with than just how close or how many seconds did that vehicle come from hitting a pedestrian. You have to look into the manner of collision, you have to look into the speed of the vehicle, and you have to see who crossed first, the pedestrian or vehicle, all contributing factors. So right now we're focusing in on only mid-block through movement conflicts So those conflicts such as this, where you have a through movement vehicle away from a signal, where it's really difficult to argue that there isn't at least some sort of safety concern here. The pedestrian's crossing outside of a crosswalk and coming within a few seconds of hitting a through movement vehicle. So on a road safety audit we did in Jessup, Georgia, we identified 5 potential crossing locations that were looking to install a pedestrian hybrid beacon or some sort of mid-block countermeasure. These were all identified either from a local government, GDOT staff, or consultant in that road safety audit. The first thing we did is calculate our observed benefit cost ratio for each of those 5 crossing locations. If you're familiar with how we do safety analysis, we calculate the expected crash reduction in an economic dollar value over the life cycle of that safety improvement, and that's your benefit cost ratio. But that only deals with crash data right now and what that existing crash data is. The problem with pedestrian crashes and why we're honing in on this conflict detection for VRU safety is, well, PED crashes make up less than 1% of our total crash data, but nearly 20% of our roadway fatalities. So that has to do with underreporting, and well, people just don't shake off a crash sometimes and it does not get reported. So we're really dealing with minimal data sets with pedestrians. So we've ventured into conflict detection now to really just give us more data points to deal with and make informed decisions. So we need to get those conflicts in some sort of economic dollar value, similar to the same way we came up with an economic dollar value for crashes. So we're leveraging an ITE method that was developed in 2021 with a kinetic energy model. So assessing speed, manner of collision, and different conflict types for an economic dollar value. We tweaked this model just a little bit. The first thing, well, all the manner of collisions that we're dealing with is actually just PED and that through movement PED crash, so it's constant in all the scenarios we're looking at. And the economic dollar value is actually just calibrated to our local corridor conditions. Our total economic dollar value for PED crashes is not changing. We're just giving ourselves more data points at each location. So what we did was we took 50% predicted crash cost from those conflict detections and 50% crash costs from, well, what the actual crashes that occurred along the corridor. Why did we do 50-50? Because it's very simple to get our expected crash cost and calculate an expected crash reduction and expected benefit cost ratio. So a few things I want to show you on those same 5 locations. The first one we looked at had that observed benefit cost ratio where we were only dealing with crash data of around 46, a very competitive benefit cost ratio when it's just observed. Well, there weren't that many predicted crashes there or conflicts at that location, so we didn't want to ignore the crash data, so we still have an expected BC of 24, a project we can still program. Then we have 2 other locations, a BC of around 3.7 and 2.3 when we only look at observed. Those are the 2 on the bottom of the screen here. Well, those 2 would not have been programmable of a project for our safety program. It's just very low BCs competitively. But when we take a look at conflicts, we had many more people crossing and getting into near collisions at those 2 locations. So those had very high predicted BCs and therefore more high competitive expected benefit cost ratios that we can use to help justify these in a project. And then the far right location, we originally had an observed benefit cost ratio of around 8.5. But if you remember what I said earlier, we're dealing with very minimal data points. In each of those PED crashes, they can get picked on, and sometimes they're not actually safety concerns. They're kind of freak instances. So what we found there were 0 conflicts when we put our video out there. So that one led to only an expected BC of 4.3, kind of became less programmable of a project or less competitive of a project. So really using that conflict detection data to supplement our traditional safety analysis to make a more informed decision with more data. So outside of conflict detection and outside of all the ETC data now, there's a lot of data we're also looking at within the safety program. friction supply and friction demand are two data points we're looking into. Friction supply being what is actually physically on the road, collected usually from a vehicle driving over that road. The friction demand comes from connected vehicles and the lateral forces on there. That should be on the ETC shortly. And then dash cam data, we actually have a signage data set from Here Data that's available but not really publicly accessible just yet. And looking into all sorts of other data sets that can be collected from dash cam data. And then aerial imagery, that's under procurement now. Hopefully we should get that soon. That's going to range from 15-inch to 3-inch per pixel, which is extremely high quality, that 3-inch per pixel, which will be in our urbanized areas. And I can't wait to see all the different AI algorithms that can be used to detect different roadway assets with that aerial imagery data, which is simply collected from planes flying over us constantly, which is pretty crazy, I think. All right, so back to those 3 key takeaways that were brought up at the beginning. We have a variety of new data that's available for GDOT as well as our extensions of staff, and much of that's local governments as well. Making that validated data available across an entire roadway network can help us save cost and encourage collaboration between our agencies. And then finally, these new types of data can enable data-driven proactive safety analysis as well as much other types of safety analyses. So thank you guys very much. Let me know if you have any questions.
Okay, thanks to all our presenters. Now we'll open the floor for any questions. Catherine?
All right, last time, Catherine Johnson, data nerd. I've got 4 questions. I'll try and make them as quick as possible. First one is for Natalie. I looked online, and the estimated population of Gwinnett is 975,000 as of 2022. I just wanted to ask, what's the ideal amount of app installs to really have the effect that you wanted to get from the GMAP from the GMAP app?
Yeah, so so first off, I do want to just clarify the study area and the area that will serve this application is within the fixed route transit routes currently. So that's, I think it was like half a mile, 3/4 of a mile of those fixed route transit routes. So that's the area in which the pedestrian inventory data is. That's the area that will be able to support the best application. We have a goal of 1,000 end users by the end of phase 3. So that's our kind of first goal. And then, of course, during that operations post-deployment phase, we would like many more than that. But yes, so help us make our goal when that application comes out, please.
Thank you. The next question is for Dolores and Anslee. I'm a little biased because I work with Anslee. Anslee, I'd like for you to highlight some of your user engagement that you do for through 511. Specifically, you had something that you put out about the Olympics.
Yeah, so we try to engage a lot of our fans online in different ways. And so a big portion of the content that we put out is going to be incident coverage, things that are happening on the roadway, but also it's very important for us to humanize 511 as well. So from a communication standpoint, we're also looking at sharing the stories of our operators, the teams, the dedicated teams that are behind 511, and then also trying to find different ways that we can connect with social media as well, because that is our overall goal. Is we want to, definitely be on the forefront of real-time traffic information and a source, but we still also want to have engaged users that are come back to our pages. So the example of the Olympics that Catherine is referring to is we did an example of this trend on social media, and we did 511 Olympics and how we got the gold in 24/7, 365 support, right? We got the gold in real-time traffic information, and we also used, and there's some other ways in there, but it was a way for us to take our overall mission, humanize our brand, show, what we can provide, but then also tack it on to something that was maybe relevant and timely within that moment. So,
Thank you. It was one of my favorite posts. Next, we've got Chris and Kamari. I really like that you guys are helping out with the crash reporting tool. I have struggled a lot, so it's definitely helping me out. Do you have a number so far on the reduction of the errors that you've had just by implementing this alone?
No. No, we can connect offline, but we haven't studied that as a part of this deployment.
I'm pretty sure it's significant. Thank you. And then last one for Ron. It's not a question. I'm just really excited. Actually, I guess it is a question. Is there a listserv or anywhere that we could get updates for data that's coming out? Should I just follow CatLab or look for it? Because I'm really interested in the waypoint data once it's validated and ready to go.
Sure. Yeah, I think the goal is to publicize that through our joint data purchasing committee. I'm not sure we have an email blast out now, but we're going to be trying to let everyone know at every upcoming conference that we can.
Sounds good. Thank you. Those are my questions.
Other questions?
My name is Michelle Arnold, and I happen to be the pre-construction division director for Gwinnett County. So we have over 1 million people, by the way, and still growing. This question is for Alan Davis and Natalie. Where can I get the sidewalk inventory tool? We have our SPLOS programs with pedestrian safety projects, and our community services department is in the process of updating our trails master plan. And we also won a SS4A grant and developing an action plan. Thank you.
Great. So we're finishing up that data collection now, and then it will be available. We've actually worked with Matt. I can't remember his last name, I'm sorry, but who is currently the ADA coordinator as well at Gwinnett County, to make that data available, so he knows it's coming too. So we can connect right after this, and I can make sure to let you know when it is available and how to access it and stuff. We'd love for it to be used more broadly, and part of one of the features of the application will be that folks can put in if there is sidewalk missing, or if, so they can be able to identify that. And then we're currently figuring out how that information gets to the appropriate people at Gwinnett. So would love to get your feedback in on that too.
Natalie, one question. I know you haven't gotten to this point yet, but how do you plan on reaching out to people regarding the application? I know you're not there yet, but I'm just curious.
Okay, I'm so excited about this. I don't know if you all know this, but so Gwinnett County has been amazing to work with, and specifically their group that does outreach. And our app is focused on supporting those with disabilities and older adults and so forth. So, for example, the Gwinnett County Aging Services has a newsletter. They also have asked us to go to, once the application is live, we're not quite there yet, but once it's live, we'll go to, they have, I'm trying to remember if it's quarterly or monthly, but at different senior centers throughout the county. And, okay, here's the coolest part. They also are going to let us post a little blurb and the app link to download it in their water bills. So if you live in Gwinnett County, get ready, because it's going to be in your water bill. Yeah, so smart, right? I never would have thought of that.
Because not everyone has that. And I just was going to say, like, going to senior centers and all that kind of stuff is just so critical for what you're trying to do.
And also, so we have SILC, so Statewide Independent Living Council of Georgia is a partner through phase 1 and phase 2. So I don't know if any of you know Jordan Hall, but she is a force to be reckoned with. And she has amazing connections throughout the state with all of the disability advocacy organizations. And so she's really connected us with folks that can help us and have helped us along the way. Like what I mentioned about, like, that's way too many questions. You know, so we've had them help with design to make sure that we get it right. And then also they are going to be able to support and have accepted responsibility of supporting during the travel trainings. So a lot of these organizations have existing travel trainings that, you know, help support their communities. And they're going to integrate a module that we're going to develop for them for the app as well.
And then one other question. Ron, I'm Terry Johnson with INRIX, but I know the INRIX data, the trip path data and the OD data is available to all the GDOT folks, and then any public sector agency and any consultant working for any of those agencies. Is that the same with the other data sets?
Not the waypoint data just yet, but all the other data sets it should
Okay. I just want to make sure that consultants here know that they have access to that data.
Yeah, the waypoint data, we have a 50 license, but yeah, everyone should have access to all the other data sets that I spoke on today.
Great.
I had a question. So Ron, you had showed the replica data, I believe, that had turn and movement counts, but that at this point is still experimental or kind of planning level. Is there any plans to make that useful for actual analysis, like beyond just experimental? Is that a goal, or is that possible? Or
Yeah, that's why we got it now. The goal being, I sure would love to replace turning movement counts, but yeah, I just don't know how reliable that is right now. So I think when we go collect turning movement counts, we're going to try to compare it to these.
Any other questions out there? Okay. Well, it looks like we're a little ahead of schedule, about 10 minutes or so. But please give a round of applause for the presenters up here. Okay, I'm gonna turn it over to.
In an effort to not keep y'all here any longer than you already are here, we'll go ahead and stay moving. I just want to give a thank you to every single one of you that are here. Again, thank you for your support of this conference and for your support of ITS Georgia. I think it was a great conference, and I really enjoyed seeing you all and connecting with everyone. And I hope we will continue to see you at monthly meetings and future, well, we won't have an annual meeting next year because of World Congress, but future ITS Georgia annual meetings as well. Also, thank you to our sponsors. Again, it would not have been possible to do this without our sponsors. They really helped us out and did a great job. Thank you to all of our speakers. We had some really great presentations. I was super impressed. I was here for all the presentations, and every single one of them I thought was fantastic. And last but not least, if all my green shirt people can stand up one more time, and we can give them one big round of applause. And with that, I'm going to bring John up to speak, do a quick closing announcement. He's graciously agreed to do that for us, and then we will do our raffle, so make sure you hang around for that. We got some good stuff over here. John Hibbard is the Operations Division Director for the Georgia Department of Transportation. His responsibilities include the oversight and direction of the State Maintenance Office, the State Utilities Office, the Office of Traffic Operations, and the Office of Transportation Data. John's 38-year career includes stops at several engineering consultancies, as well as Cobb County DOT. John is a graduate of Georgia Tech. Woo, go Jackets. He's involved with the increasingly automated world of transportation and is, per his wife, fascinated with all things technology, much to her chagrin. Please welcome John Hibbard.
And if I could, before I get started, would y'all join me in a big round of applause for Madison running this show? Seriously, this has been such a well-run affair, a lovely place, and so glad to have been here with y'all over the past couple of days. Alrighty. I was all set and ready to go. I got notes, I got stuff, anyways, and then this morning happened, right? What happened this morning? Well, Alan and I got an email from the commissioner. Now, understand this happens, okay? And inevitably this happens, and it's usually, yeah, we wrap Dolores and Christina into it because it usually has something to do with an incident. Because he does, yeah, he asks, why are we doing it that way? Or what is going on out there? But today, no. You know where he is? He's in Dubai. He's at the ITS World Congress. That award that Ron mentioned, yeah, Commissioner's going to be picking that one up. Yeah. Yeah, boy. Now, I think it is way the heck cool that he's there, that he wants to be there, that he thinks all of that stuff, which is this stuff, is that cool. And he does. He thinks this is all just tremendous stuff. And he thinks the world of all this here. And so there is so much to celebrate and all at the same time so much to do. Over this conference, you have heard from a variety of people, GDOT people, on a whole bunch of topics. Note, you really didn't hear from Dave, although you kind of did, because Kumari and Chris were the ones kind of speaking on his behalf, and Ron K there at the end, and now you get me. Yeah, because a lot has been done, and we've celebrated that. Over the past 30 years, man, Andrew hit me with that when he gave his remarks yesterday, right? Okay, this could be embarrassing on both the ask and the answer. What were you doing 30 years ago? Anybody just not here yet? You know? Right? Right? 30 years ago, I was at Cobb County DOT. And yeah, we were getting ready for the Olympics. We only had 2 years to go. And that to me was a fascinating thing because it was one of these events where the event wasn't going to budge, so you had to hit the deadlines. Yeah, right? So over the past 30 years. But yeah, as you have heard, there is so much to do. So a lot of this is going to be recap-ish, but maybe the slant is a little bit different, okay? For a brief moment in time, I-285 and I-20 West was the biggest GDOT project ever. Yeah, the contract value for that thing is $1.2 billion and some small millions. Y'all know by now that, and that is the third of the big 3 system-to-systems that we are reconstructing. And note, all of those date back to like in the beginning days, like 1960s. Yeah, I was around, but I was, okay. When we talk about an interchange, you know, we kind of use that term loosely, and you've experienced that, right? On 285-400, yeah, it ran east and west a whole long ways, didn't it? Yeah, yeah. I-20 East and 285, which some of you may encounter as you come back into town here in a bit, that one's running a few miles each direction too, and so is this one. So even if you take ITS as just quick rule of thumb-ish, 3% of that contract sum, that's still a $37.5 million ITS project, essentially within all that, because it's happening. It's all happening. So let's go on to this one instead. And then came 400, right? Which truly is the biggest project ever. But it is a very different project. And not only is its cost, design and construction cost, $4.6 billion to build all of that, express lanes and bus rapid transit and inline transit. You heard all of that, right? So yeah, within that is a massive ITS and tolling project. And. So it's got even more than. Oh yeah, and there's this thing called a concession fee. I think I got all the zeros right there. It's in billions. And that's money that they bring to closing. Yeah. Closing, by the way, on a project like this big is about a year and a half off. It takes a minute to line all that stuff up. All to the good. Oops, I keep turning the screen off. There is obviously in this a new approach to operations and maintenance because this whole thing is, you might call it revenue risk or you might call it a concessionaire project. And they are both maintaining, the developer, maintaining and operating, the express lanes, but you knew that, right? And the general purpose lanes. All of it. Casually, the phrase that we used as we continue to kind of develop the scope on this thing was fence to fence. Right-of-way fence on this side to the right-of-way fence on that side. It's all theirs. So, when you go down that path, then think about this stuff. A whole lot of interfaces and interactions. Very real-time stuff with TMC Ops, with Hero Incident Management. They will be handling incident management on the road, but yet there's an interface, right? And, oh yeah, that thing called TRIP, the TRIP program for heavy crashes. They'll have them too up there. They do. But so much, all those interfaces, I mean, there's interfaces, physical ones, between, this section of road is GDOT and that one is the developer. But so much of what I've just put on the screen is very much real time and live. And we, the operations world, will be living it. So let's go from extreme to extreme, right? You want a weird program? Yeah. Welcome to Nevi. It's a whole bunch of weird. Us doing things that we've never done with people that we've never worked with before. What could go wrong, right? Each site is its own project. You can talk to Christina about that. Programming, how many? 38 total projects. That's what it is. 38 different PI numbers. Yeah. Each site is its own P3. Own, standalone, public-private partnership. Notice everything I've talked about so far is what we would lump into alternative delivery. And frankly, everything I'm going to talk about for the rest of this thing is too. Even these. And each one of them is easily less than $1 million a pop. And yeah, they're all managed by traffic ops. Thanks. But practically speaking, who else was going to do it? Small, discrete projects, they all need power, a lot of power. They all have comms needs, although a lot of that will be handled cellularly. Whatever is being planted there, it's kind of a techie gadget. It is not simply build and install, but also to operate these things for 5 years, which is, that's, a whole bunch of weird there. Thank you to the federal government's Joint Program Office for all that. But in a sense, it almost kind of smells like a traffic signal or a CCTV camera, something that we want designed and installed so that it can be operated for a good long time. Kind of get how we got there, right? I really just wanted to put this slide in because I wanted the ability to show you an electrical outlet in the middle of a presentation. I thought that was kind of neat. I know though, I owned a Nissan Leaf back in the day. like 2012, 2013. Anybody? Anybody there with me? Over there? There you go. That's right. This is how we plug those. This is how we charge those suckers up at home. Now, who has an EV today? There's a couple of you, right? Right? Yeah. Use one of these, or use the 30-amp circuit to charge at home. That's better, because you got a whole lot more range than the 80-odd miles that I had in the Leaf, right? But yet, in the world of our NEVI program, this is what we're talking about, okay? And it can use either of those two, left and right, CCS, that's a typo, oops, or the NACS or Tesla charger. But yeah, that's big voltage right there. And so you see power company considerations and all that kind of stuff. So we are procuring the remaining AFC gap sites, and Christina talked a lot about that. 33 of them. Proposals are due at the end of this month. They're P3s. It's streamlined to the greatest extent we could streamline it. It still is big and kind of clunky times 33. So hang on, we'll see how that plays out. Christina summarized the first 5, and they were all very familiar names, right? You know, everybody knows Waffle House, right? Go to Tifton, charge your car. Shell gas station, racetrack. That's what the one in Dublin is. That's a racetrack site. Love's down in Brunswick. Us doing business with retail providers. That's all very new and different to us. But let's jump into that last thing that Ben talked a lot about yesterday. All of it. And you want, here we go again, right? I talk about very different projects, and that's so much of everything I've been talking about. 19 counties, 155 new poles being stuck in the ground, with 173 new roadside units, and 1.7 million feet of conduit. Just putting scale on it, 1.7 million. And that's just Design Build 1. That's just the blue line there. Design Build 1 more than doubles the amount of fiber we already currently have along interstates. Just that one. And then Design Build 2 adds another 1.1 million feet of conduit and more than 100 poles and RSUs, and runs through another 16 counties. I mentioned the counties. You saw me do that twice because that crops up as a peculiar issue. Most GDOT projects are in one county. Sometimes they lapse into a second county. Not 16, not 19. Makes for interesting, complicated project, long, skinny projects, and Ben told you there's good chunks of it that are literally 2 inches wide. That's it. And then lay on top of it this thing called the OMC. It's a P3, but it doesn't build anything. But it is so critical to essentially ensuring the maintenance of things, facilitates rural broadband. You heard a little bit about that, preparing us for that connected autonomous world, and desirably covering its O&M costs. Some of you all that have suffered through me before know that I will sometimes question where the apostrophe goes in ITS, and I will let you all decide where it goes there. You remember this guy from Andrew's presentation. He's not the only one walking to Florida. I see Michael Presley back there. We have C and I too. They'll be walking too. And then add to it this concept, and you heard a little bit about it earlier, that it's a moonshot initiative. So this guy's worried that he's going to have to go further than Florida, but no, not at all. Moonshot winner. And my point in all this here over these last couple of slides, and yeah, I am almost done, is that AASHTO, which is that organization that is the organization of all state DOTs, is thinking hard on what does the future look like. And look at the kinds of words that are here. You don't see the word road in that paragraph. Communities, people, and goods, and partnership. If you've ever heard our commissioner talk, He will talk a lot about y'all, whether y'all are GDOT or y'all are our partners for how we make this all happen. Notice again here, non-traditional partners. Witness the prior slide on that OMC thing. That will be a non-traditional partner. They ain't in this room, I can assure you of that. Advancing a small number of moonshots. And our broadband program was selected as one of those. That page there off to the right lists all of the different states that are part of this, that were also selected as moonshots. You see Nevada there, Minnesota, Michigan, New Jersey as examples. But my point in all of this is that we are, notice the verb tense there, doing it. We're doing this, all of this in this room. We are making amazing things happen. As our commissioner emailed Alan and I this morning, asking us questions about connected vehicle RSUs and how much do they cost and how many and so on and so forth. You can tell he's being asked a lot of questions about what we're doing in Georgia. So here's to the next 30 years. Drive safe. Thank you all for your time and attention.
Thank you so much, John. All right, we're going to get on to our raffle soon, but I just want to close things out for our virtual attendees. Thank you to everyone who joined in and live streamed with us, and we'll see you next year. All right.